A very good day to Dr. Nazif. We are Group 1 from CHM3252K2, which is Natural Product Chemistry. So today we're going to present our group assignment for this course, and the topic of our group is berberine. So before we start with our presentation, I would like to introduce my group members. So the group consists of me, Lim Wai Lun, Yong Xing Yi, Dahia Najiha, and also Kojai. So basically, there are a few sections in this group assignment, including applications, chemical structure and class of compound for berberine, building blocks and biosynthesis, as well as chemical synthesis in the lab. So I'll begin with my part, which is applications of berberine in real life. So berberines have been studied and proven to consist of a lot of properties, such as anti-inflammatory, neuroprotection, and also vascular protective properties. So therefore, we believe that there is a lot of applications of berberine as a natural product in diverse fields, especially in medicinal and also nutrition field. So the applications of berberine that we'll be discussing today will be reducing blood sugar in your body, reducing heart risk, and also as a supplement for weight loss. So the first application we'll be discussing today will be reducing blood sugar in human body. Alright, so the researchers believe that berberine has the ability to reduce the insulin resistance in the body, which allows for more effective blood sugar lowering hormone, which is called as insulin. Other than that, it also increases glycolysis, where it is a process of breaking down carbohydrates into glucose for the cells to generate into energy. And it also helps reducing sugar production in liver, as well as slowing down the breaking process of carbohydrate in the mouth, the gut. Right? So this all helps to reduce the use of glucose instead, but they use sugar so that sugar are mainly reduced in the body instead of glucose. Right? So after that, berberine is also known for its reducing heart risk properties. A clinical study has conducted which shows that berberine is actually able to reduce the total cholesterol, low density lipoprotein, LDL cholesterol, and also blood triglycerides, as well as increasing high density lipoprotein cholesterol HDL. Berberine has a potential in improving heart failure by enhancing the calcium handling in the heart cells by the CAMP, which is also called as cyclic adenosine monophosphate. This helps strengthen the muscle contraction of the wall in the heart, which improves the blood circulation around the body, which reduce the risk of getting heart diseases in the community. Alright, so another study also said that berberine has a potential in treating a lot of cardiovascular diseases, including atherosclerosis, ischemic stroke, as well as coronary heart diseases. So last but not least, the last application for the berberine is actually it is a supplement for weight loss, because a lot of research has been conducted which shows that consuming berberine will result in reduction in body mass index (BMI) and also belly fats, because they believe that berberine when you consume berberine, it will actually inhibit effects on the growth and accumulation of fat cells at molecular level. Other than that, they also believe that berberine helps triggering the activated protein kinase enzyme AMPK, which plays an important role in regulating the body mechanisms. So it also helps slowing down the process of digestion, also allowing effectively absorption of glucose in the body, so that accumulation of fat cells or even accumulation of glucose does not appear to store in the body.
The structure is complex, where it has 5 connected rings, making it a type of heteropentacyclic compound. It also contains a quaternary ammonium group, which means it has a positively charged nitrogen atom built into the ring system. This positive charge is delocalized across the molecule, making the structure more stable. Berberine is also a very flat and planar molecule with lots of conjugated double bond and metal state groups attached to its aromatic rings. This feature gives it its bright yellow and a bitter taste. Berberine is a natural compound that belongs to a group of plant-based chemicals called isoquinoline alkaloid. More specifically, it is a protoberberine subclass. These alkaloids are characterized by a tetracyclic structure derived from the benzyl tetrahydroisoquinoline system, forming a 5,6-dihydrobenzo-A3-quinolizinium skeleton.
For berberine is number 1, C1, composed of a single carbon atom. Number 2, C6C3, phenyl propyl unit. Cleave remove 1 or 2 carbon to form C6C1 and C6C2. Number 3 of building block is C6C2N. From L-tyrosine, carboxyl carbon or amino acid is removed. fourth one is C6C2C6. This is the flow of biosynthesis of berberine. Start from L-tyrosine, then have some mechanism, then it will produce berberine.
Alright, since on my part, I'm thinking and I'm explaining the components of berberine. So before the main components, there are four chemical syntheses of berberine in the proteins. So they are chemotherapy, donohoid, and ketone. So among these four, the donohoid actually is the most efficient synthetic group of berberine and yield the most, which is 50% heat. So now we move on the main synthesis work we need to discuss in this study, which is carried out by Marie. So they synthesis the compound 2B in the drawing by using the 2A and 2B through the pictures with the reactions. And then they want to convert the compound 2B into compound 2C, which is the berberine directly, but this is fueled by the formalin switch reactions. So they propose a new reaction with onto this. Alright, so this is the successful synthesis work into synthesize berberine. So they will involve reduction animation. After that is treated by the triatic acid to promote a further cross outpacing alkylations. And then the third step involves the enzyme elimination of methanol. And the fourth step involve the oxidations using iodine in the presence of potassium acetate, and lastly the berberine is successful to be synthesized.